Today we're going to take a look at fractions. Now a lot of people don't like fractions, and I think that's because they don't really understand what a fraction is. All a fraction actually is, our definition, is just part of a whole. So we all know what a whole thing is, but if we take a whole thing and cut it into pieces, then we can take pieces without taking the entire thing, whatever it is. So the classic picture that we normally draw is something like a pizza. Let's say that we cut this pizza into 4 pieces. Now being that it has 4 pieces, we can call each one of these pieces a fourth of the whole pizza. So if we were to eat 1 piece of pizza, we would have 1 out of the 4 pieces, or 1/4 of the pizza. So when we're looking at a fraction, the top is called the numerator, the bottom is called the denominator. Now those are the scary math words about it, but all it is this. The top tells you how many you have, and the bottom tells you what they are. Now this is something that we do easily in real life. Like if I said we had 2 cats, right? The number out front tells you how many we have, and what's after it tells you what they are. So I have 2 cats. So if I had 3/4, it kind of makes sense like this. We just need to know what a fourth is, right? So 3/4, which can also be written as 3/4. So you see the top tells you how many, the bottom tells you what they are. So let's go back to our pizza for a second. When we last looked at it, we had eaten 1 piece of our pizza. Now, if we had eaten, like we said a second ago, 3 pieces of this pizza, we would have eaten 3 out of the 4, or 3/4 of the pizza. All right, let's take a look at a couple more pictures and see if we get the idea on what a fraction, at least the concept of a fraction is. Let's draw something like this. All right, act like those all those pieces are the same size. So we have one thing here, we have one rectangle, and it's cut into 1, 2, 3, 4, 5 pieces. So each one of these pieces is considered 1/5. So if we were to say, I don't know, what would the fraction be of the total rectangle if we took out these 3 pieces? Well, we'd have 3 of the 5 pieces, or 3/5 of the picture. All right, let's try another one. I'm gonna draw a picture for you here and see if you can come up with how many pieces it's broken into and what part of the fraction we have. Let's say we have, okay, so let's say we have that much. So do me a favor, see if you can write the fraction that represents the shaded part of this diagram. You got it? Let's see. We have one rectangle, it's kind of turned on its side in this case. Here, this rectangle was cut into 4 pieces, so we know we're talking about fourths. And how many pieces do we have? We have 2. Now later on we're going to see how to reduce this fraction, because 2/4 is really the same thing as a half, right? By looking at this picture, we have half of that rectangle, and like I said, a little bit later we're going to see how we can reduce this 2/4 into a half. All right, let's go back and do a couple more pictures. Let's say we have squares like this, and they're cut into boxes. Let's do one more. Cut into boxes. Okay, so here this is a little bit different than what we've talked about, because in the last several pictures we were just looking at one shape cut into pieces. Here we have 3 shapes cut into pieces. But notice all the pieces for all the pictures are the same size, right? This is one thing cut into 4 pieces. This is basically the same thing cut into 4 pieces and cut into 4 pieces. So if I were to shade something like this, shading, and this, how could we represent this using fractions? Well, since each one of these pieces is still a fourth, I know we're going to do this out of fours. So how many fourths do I have? Well, 1, 2, 3, 4, 5, 6, 7, 8, 9. So here we have 9 fourths. Now, another way that we could represent this is say, well, we have two whole things and one part of another. So we could also represent this as 2 and 1/4. Now we've introduced two kind of new things here that we haven't seen in the past. This is the first time we've seen a fraction where the top is bigger than the bottom. So this is called an improper fraction. And I'm just going to say top is bigger than the bottom. Or the numerator is bigger than the denominator. Now this is really a poor name for something. Improper fraction makes it sound like there's something wrong with it, right? It's improper. Well, there's nothing wrong with it. In fact, a lot of times we're going to prefer improper fractions over this form, which is a little bit more useful in some cases. This is called a mixed number. A mixed number has a whole part, right? In this case, we had two whole things and a fraction or part of that thing. So mixed numbers and improper fractions can be used to represent the same thing. To be honest, if you're actually doing arithmetic, math with things, improper fractions are a lot better. However, if you were doing something, say, a little bit more real world, like baking a cake, mixed numbers are actually much better. I mean, think about it. If you were baking a cake and it said, give me 9/4 cups of flour, that's not really instinctual. Like, I'm not real sure what that is, but if it said, give me 2 1/4 cups of flour, that would make a lot more sense in that situation. The problem is doing arithmetic with mixed numbers is a lot more difficult than doing arithmetic with improper fractions. So since both of these represent the exact same quantity and both of these have their own uses, we need to be able to go in between both of these. We need to be able to rewrite an improper fraction as a mixed number and a mixed number as an improper fraction. So let's take a look at that. Let's see here. Let me get all this out of here so we got some room. Let's see if we can go from, let's do a mixed number to an improper fraction. Okay, so here's what you do. Let's say we had our 2 and 1/4. Now this is really just a multiply and add, and I'll write this out in a second. You take the denominator times the whole number and add the numerator. So we do 4 times 2 plus 1, and it stays over 4. So we're going to do the 4 times 2 plus 1 all over 4. Of course, that's 8 plus 1 over 4, or the 9/4. So denominator times whole number plus numerator all over denominator. So denominator times whole number plus numerator all over the denominator. Now, writing it like this using all the math words is pretty messy, kind of ugly to kind of think about like that. But just once you do it a couple times, it's pretty easy. So 2 times 4 plus 1. So let's try just a couple more of these. What if I had 3 and 2/5? So we can actually get to the answer faster, but I'm going to write a step in the middle. 3 times 5 would be 15 plus 2 is 17. So this would be 17/5. So what do? We do 5 times 3 plus 2 all over 5. 15 plus 2 over 5, which would be 17/5. All right, quick and easy, right? And again, you don't need to show these steps here in the middle, especially when the numbers are small like this. If you can go from the mixed number straight to the improper fraction, you probably should do that. Let's try another one. How about 4 and 2/5? do me a favor, take a second and see if you can write this as an improper fraction. Did you do it? All right, let's take a look. So denominator times the whole number plus the numerator. So 4 times 5 is 20, plus 2 would be 22 over 5. All right, now we're going to really need to be able to do this a lot by the end of this chapter, so make sure that you know how to convert a mixed number to an improper fraction. Now, the way that we do less is going from an improper fraction to a mixed number. So let's do that the other way around. So let's do an improper fraction to a mixed number. Well, to do this, we got to realize that there's another way to look at fractions. So if I had, let's do 7/3. Now, with our first definition, we said that these were parts of a whole thing. So here we have 7 things, and these things are thirds. So if we have a bunch of things cut into thirds or into 3 pieces, here we would have a total of 7 of them. How do we figure out what the mixed number is? Well, another way to think about this is division as well. This is 7 divided by 3. So to do 7 divided by 3, we would write it like this, 3 into 7. So we'd ask ourselves, how many times does 3 go into 7? Well, the most it can go in would be twice, because 3 times 2 would give me 6, and when we subtract, we have a remainder of 1. So here we have a remainder of 1. So here's how you do it. 7/3 is the same thing as, since 3 went in twice, that would be 2 whole ones, and we have 1 left over, so we would still have 1/3. So you're going to do the numerator divided by the denominator. The number of times it goes in evenly will be the whole part. The remainder will be the numerator of the fraction that is left. Okay, so we're talking about how many thirds we have. Here we had 7/3. That ends up being 2 whole pieces and 1 more third. So let's try a couple more of these, because it's really the division that kind of throws people off. So let's say we have 17/5. All right, so just to kind of practice this, hit pause and see if you can do the division here. See if you can do division and figure out what our remainder is. All right, you're back. Let's see. 5 goes into 17. Well, the most times it can go into 17 is 3 times. That would give me 15. And when we subtract, you see we have a remainder of 2. So since it went in 3 times evenly, we can say that the whole number is 3. But we have 2 left over. Since these things are fifths, we still have 2/5. All right, let's try one more. I'm gonna come back over here just so we're centered a little bit more. Let's say that we have 9/2. All right, again, hit pause and see if you can write this as a mixed number. All right, let's see how you did. So another way to interpret this is, we have a whole bunch of things cut in half, and we've added those up and we have 9 of the halves. What would that be in terms of a mixed number? Well, another way to think about this is division. So this is 9 divided by 2. 2 will go into 9 4 times. That gives us 8 with a remainder of 1. That means we'd have 4 whole things with 1/2 left over. Okay, so being able to convert from improper fractions to mixed numbers and mixed numbers to improper fractions are going to be quite helpful, especially going from mixed numbers to improper fractions. So make sure that you can do that. But let's take a look at one more weird thing that can happen when we're dealing with fractions. Let me go over here real quick. Let's talk about fractions and zero. Anytime there's a zero involved with a fraction, people tend to get really confused. Now, let's think about another way that we can look at fractions. We said it was division, right? So if I had something like 20 divided by 5. Now, we could think about this as we have 25ths as well. Like if we have a whole bunch of things cut into 5 pieces, we have 20 of those pieces. But right now I want to think about it as division. Now remember, the concept of division is you're splitting something up into a bunch of pieces, and we want to know how big each piece is. Something like this. If we have $20 and I want to give it to 3, 4, I want to give it to 5 people. I'm going to split that $20 up among 5 of my friends. How much would each person get if they all got the same amount? Well, in this case, you can pretty easily see that everybody would get $4. Right? That's the size that everybody would get. So 20 divided by 5 would be 4. Okay, so division is cutting things into pieces, and the answer to division is the size of each piece. So if I had the same $20, right, same $20, and I wanted to divide it among 2 people, how much would each person get? Well, each person would get $10. So 20 divided by 2 would be 10. All right, let's bring some zeros in here, because here's where it kind of gets confusing. Get that out of there real quick. What if I said 0 divided by, I don't know, 7? Well, this one should be easy for you now. If you have no dollars, right, you have no dollars in your pocket, and you want to give it to 7 different people, split it up. I know it's only 4. How much would each person get? Well, since you had nothing to start with, cutting into the pieces doesn't change that. You still have nothing. So 0 divided by any number, except for 0, we'll talk about dividing by 0 in a second, this is always 0. Right? You've got nothing, cut into a bunch of pieces, you still got nothing. Now the other way, this is one that really gets confusing. This one actually doesn't really make sense at all. What if you have 1 pie and you cut it into no pieces? Right? This is saying we got like 1 pizza. So if we have a pizza, how do you cut a pizza into no pieces? Because that's what it's saying, right? Cut this into 7 pieces. It says cut something into no pieces. Well, if you have something like a pizza, and you don't cut it at all, you got 1 big piece of pizza, right? So no matter what, you have 1. So this doesn't even make sense. The question itself is broken. So if you have a number divided by 0, we say that this is undefined. Undefined just means it doesn't have a value, so it doesn't really make sense. So in this case, a number divided by 0 is always undefined. Now in both of these cases, I'm assuming that this number is not 0. If you have 0 over 0, that's a big problem that we're going to deal with in the future. But remember, 0 divided by anything is 0. Anything divided by 0 is undefined. All right, fractions. Remember, fractions are just part of a whole thing. The top tells you how many things you have. The bottom tells you what they are, like 2/3. You have 2 things, those are thirds. You do need to be able to convert between improper fractions and mixed numbers. And kind of remember our rule for dividing by 0. It'll be helpful in the future.